Right. Good morning, everyone. I hope you can hear me and see the slides. Is it all good? Can you hear me clearly? Okay. So my name is Azmeer. We'll be looking at software quality assurance from today. Before I go into quality assurance, I think we also need to look at what is quality assurance and why it is important to learn this. So what I did was I looked around at some of the areas where there were some issues, some problems happened due to lack of quality assurance. And I listed some very interesting video clips for you. So we'll get to that in a minute. Maybe I can show you the website. Well, it's in our LMS. Switch to that. Right. So I hope you can see the LMS. If you go down to, oh, by the way, the top section is completed. So you can see the module information. So you go down to here, week 1, I have some very interesting case studies. Okay. Starting from the Ariane 5 failure, that was a very expensive rocket that the European Union was trying to send. And due to a software glitch, the whole thing crashed. So likewise, there are a few others also. There is the second one, deadliest software crash. It's about medical equipment. Due to a software glitch, it killed people. Right? Now imagine that, killing people because of bad software. So the question is, who tested the software? Right? What happened to their quality control? So that is why we need to study these things. And then the third one was happening from 1999 to 2000. So that was called the year 2000 bug, or Y2K bug, popularly known as a Y2K bug. Again, it was a software glitch. Can't blame the people, because if you go back to the history of computers, 1970s, 80s, where computer memory was very expensive, the programmers tried their level best to use as less memory as possible. So one of the decisions many people took was to use 2 bytes to store the year. So for example, to store 2024, you need 4 bytes, 2024. So what they did earlier was they stored the last 2 digits only, 24, right? Whether you store it in 1 byte or in a data structure that consists of something else, it doesn't matter. But the fact is, they use only 2 digits to store the year. Now, what happens when you move from 1999 to 2000? So the last 2 digits go from 99 to 00. Now, that's a serious problem, because if you do date calculations, you can't get it very well. Yeah. You have a 0 now. So although it's not actually 0, it is 2000. So that was a serious problem. So that was one very famous software problem. So a lot of companies had to rewrite their software. In fact, due to that, many outsourced industries born. They had to recode a lot of stuff. And most of these programs are written using very old programming languages like COBOL and stuff like that, Fortran. So there were huge demand in the latter part of 90s for programmers to rewrite code to basically transfer into 4 digits. And the next one was NASA, another very interesting probe. They were sending a probe to space, and two sets of programmers. One was using imperial, like the inches and foot kind of measurement, whereas the other team was using centimeters and meters. And they never had any chance of testing the software. So the whole probe was lost, right? It crashed. So again, another $1 million loss. Now, all these things, all these examples are there to show us the fact that software, not hardware, right? Software is also very serious. And when you are developing software, you need to put some very serious effort in testing them, right? All these problems happen because someone didn't put attention on testing it. Or testing was not part of the software development. Okay. So we understand all these issues after, millions of dollars of lost lives and lost of equipment, money. In fact, the last one is another very interesting one where they lost. Actually, if you click on any of these, it'll also show you the detail, right? I quickly show you that. So if you go to this one, so there's some bullet points here, right? The Ariane 5 rocket developed by the European Space Agency experienced a catastrophic failure during the maiden flight. So the first flight, it failed. So the software bug caused the overflow error. So if you go through the video, it will explain you what is happening. So they had a 64-bit calculation going on and trying to store the result in a 16-bit number. And it failed, obviously, because it overflows. Now, this also happened because they brought in Ariane 4 software to Ariane 5 without testing properly. That is where the fail happened, right? And if you look at the next one, oh, by the way, this is the YouTube link. So you can click that to watch the video. The next one was the Terac 25 radiation therapy machine. This was a very interesting machine built by a Canadian company. And what happened was it was giving overdose radiation that can kill not only the cancer cells, but other cells also. Again, another classic failure where software was not tested properly, right? Inadequate testing and poor design. And the next one was the Y2K bug. So I already explained what it is. It is to do with the last two digits in the date variable, yeah? And then the NASA's Mariner 1 spacecraft. So that is again a classic example of two different teams using two different calculation methods. One team was using inches, the other one was using centimeters, and obviously it won't match. And the last one was a financial company, not just the software companies, but the financial company, where they lost $400 million in about 45 minutes. Within 45 minutes, they lost $400 million, right? Now imagine that a company losing $400 million in just 45 minutes because of a software problem, right? So these are some of the issues that tells us why software testing and quality assurance is important. So this is the video link. You can click and watch it. Okay. Now that is just to give an introduction as to why software testing is very, very important. Now, when you say software testing, people assume, there's a bunch of software written by some people and all we need to do is to test it, right? You press some button here, you press some button there, and then look at the output and compare that with something. So that's software testing. No, that is not software testing, right? Software testing does not happen after the software is completed. No. It happens the day you start the software building. In fact, from the day you get the software contract from your marketing team. So it starts there, right? So it's part of the whole process. So it's very, very important. So this unit is all about how you can bring in the software testing practice to the software development cycles, right? So you see, we don't call it software testing. We have the word called assurance. What does that mean? Quality assurance. So quality assurance meaning you give an assurance to the customer saying that, look, this software was built from day one incorporating testing practices. So it is assured of quality, right? So that's the whole point of this module. And so we are looking at how you can get to the assurance, how you can assure the quality from day one. Okay. A little bit about myself. Before joining the academic industry, I've been running software businesses for a long time in Sri Lanka and also in the US, Australia, UK, and a few other places where we were building software for corporate clients. And software testing and quality assurance was one of the biggest tasks we had. So our quality assurance team was as big as the development team, if not less. Yeah, because quality assurance was very, very important. And we don't do anything, even coding, without writing the testing first. So there are lots of things about how you can incorporate testing into your development. So there is test-driven development concept, for example, where you write the test first and then you write the code. Okay. So there are lots of different ways of handling it. There is something called extreme coding. There is agile coding. Various concepts are there. All of them are there to make sure whatever you are writing is fit for the purpose or fit for the customer. Okay, so aim of this module is to introduce the software quality assurance techniques and the tools that are commonly used in the software development process. Okay, so we are looking at what is available right now. What are some of the tools available? What are some of the techniques available when it comes to software development? So, which also means we writing some code in maybe some languages and see how we can incorporate testing into the language itself. That's one side. And also other practices, like, for example, documentation. Okay. So generally speaking, developers don't like writing documentation because that requires taking them away from coding to doing something not cool. Writing documentation is boring. So how can you make it interesting? Of course, again, there are lots of different tools available. If you look at some of the IDEs, like integrated development environment, let's say you are a Java programmer and you're using NetBeans, you can bring in something called documentation block, into top of your functions or top of your classes. And in fact, you can auto-generate them as well. So the things you need to do is very little. So you auto-generate the code block and you just write maybe a line or two introducing what the function or the class is doing. That's it. And the parameters, the output variables, all that will be automatically filled in by the IDE. So when you do that, you're actually making the life easy for the next programmer who will be taking over from you, or someone coming back after 5 years to maintain your code or upgrade your code or whatever. Right? So documentation in the code itself is very, very important, and you can very easily do that. And generally speaking, the code documentation is always up to date, because later when you change the function or the class, and if you are having the practice of updating the documentation, you'll just spend few seconds to change that line, the doc block. And there are also tools integrated with your IDE that will generate a very good looking documentation. Right. So we'll also look at some of those documentation practices. Now, there are different kinds of documentation also. There is technical documentation, there is user documentation. There is also something called the API documentation. The good news is most of these things can be auto-generated with very little effort from the program. Okay, so that's very important because, like I said, programmers generally don't like writing documentation. They like writing code. So if the process is easy for them to make the documentation correct, they love it, right? So if you are planning to become a coder, developer, ever, you also need to get these practices of how to bring in the documentation as part of your code. That's one side. On the other side, how do you assure quality of your code to whoever is using that code, right? Again, there are many different practices that we will learn. Now, how do you name the variables? Are you using camel case? Are you using snake case? Or what is the standard? Or does the organization has a code standard, right? And how does the quality process work? So if you are joining a quality department now, how do you test a software, right? There is white box testing, black box testing, feature testing, integration testing. There are, again, a lot of jargon out there. So how do you figure out what to do, right? Or if you are just starting a software quality assurance department in an organization, where do you start? What are the things you need to get there? Okay, so those are some of the things we'll be discussing in this unit. So just like any other unit, this unit also go through certain prerequisite. Luckily, we don't have any prerequisite for this unit, meaning you don't need to complete any other unit in order to do this. But I assume that you have done some coding yourself, right? You have learned a programming language. What are the languages you have covered so far? Can you raise your hand if you have covered, let's say, programming in Python? Can you raise your hand, please? Okay, two. So only two people have done Python, is it? 3, 4, 5, 6, 7. Okay, that's a good number. Right, 11. Right, that's a large number. 14. All right. Can you raise your hand if you have done Java? Java, how many people have done Java? Only 7, 9, 10. Okay. Right. Okay. That's a good number as well. All right. So I'll be using then maybe Java to look at some of the concepts. We'll use Java as a language to test some of the concepts we are talking here. Okay. Like the TDD concept, doc blocks, documentation generation, and things like that. Anyone here who had done PHP? Any PHP? Only one? Oh, okay. Only one person. So PHP is not very popular. All right. Okay. So we'll go with Java then. PHP is also a very popular language. And some people ask, oh, is PHP dead? Who's using PHP? Well, PHP used by so many different companies. Facebook is a good example. Facebook runs on PHP language. PHP also has this very famous framework called Laravel. Very good, very robust framework for one reason, because it's highly documented. It's one of the best documented frameworks out there. You can very easily get something up and running with PHP. More than that, PHP is famous because it's very easy and cheap to deploy PHP-based application on a web hosting company compared to Java or Python or Node. That requires a bit of playing around with the server. PHP, it's very easy to throw in something very quickly. Okay. All right. So we looked at the prerequisite, nothing required. Looking at the assessments, there are three ways of getting marks. One is continuous assessments. So time to time, you will get some assignments, activities, things like that, which will give you 20% marks. And there is a mid-semester exam, which will give you 20%. And then there is final exam that will give you 60%. Okay. So this continuous assessments might have assignments, MCQs, quizzes, things like that. So please check your LMS time to time to see what kind of updates are coming there. Okay, so like any other unit, this unit also has learning outcomes, which means at the end of this unit, you should have these 4 learning outcomes yourself, right? So that's the objective of the assessments and also the activities, to make sure that you gain these 4 learning outcomes there. Number 1, describe the quality assurance process as applied to different software development strategies. What does that mean? So if you break that sentence, we have software development strategies. What does that mean? So there are different ways of building software. One of the oldest method was called waterfall. So we call it waterfall because it's like a waterfall. You do step number 1, you go to step number 2, then you go to step number 3, and then step number 4. It's okay when the software is not very complex and everything is clear. But that might not be suitable for nowadays because we don't have a long time to develop our software. So our software development cycle has come down. So it's sort of shrunk. So that is number 1. Number 2, things are changing very fast, including customer requirements. So customer might tell something today, and then after maybe 2 weeks, he will come back and say, look, I want to add this also, or I want to make a change here, right? So as developers, we can't say no. We need to figure out a way to come back and see whether we can incorporate that, because there might be a situation the customer say, if you don't do this change, I don't want the software, right? So how do we handle that kind of thing? So there are different methods. Like there's one famous method called the agile method, where you first write down the features and then come up with something called sprint cycle, right? And these sprint cycles are generally 2 weeks. So every 2 weeks, you have a chance to talk to the client and demonstrate what you have done so far. And there you can make decisions on your next sprint. Do we need to make any changes, or do we go on with the same thing? Do we make any priority change? Stuff like that. So in a situation like that, how do you bring in quality assurance? Now, if you have a waterfall method, your quality assurance is also very simple. You have a certain expectations in the beginning, and then you sort of check it and make sure that the expectations are met as you develop the software. But when it comes to agile kind of thing, which is very dynamic, things are changing. How do you make sure that these changes are incorporated and also changed as the sprint cycle is also getting updated, right? So there are various things we talk about. There's something called the daily stand-up meeting, where we check the progress on quality as well as delivery and demand and all that. So as programmers, we need to understand that as project managers, as product owners, we need to know all these things. So that's number 1. How do you make sure quality assurance process is compatible with the development strategy used by the company or the project, right? That's number 1. Number 2 is to understand the components of quality assurance. So what is quality assurance? What is there, right? So you need to break it down to understand these small components in the quality assurance. And then we need to do some hands-on development of a quality assurance plan. So we need to pick up a certain software development project, and then we bring in the quality assurance plan to that project. Okay. So my suggestion is to see your own project that you're working on, whether it is your final year project or your project for the semester, and then bring in the quality assurance to that project. So that way you are doing both at the same time. Otherwise, you need to figure out another project and then look at quality assurance there. So try to save time. Yeah. So by incorporating the QA to your existing project. And the last one is developing a testing plan for a small scale software project. So quality assurance is one, testing is another. Okay. So quality assurance is kind of a process that works with the software development process, making sure you are doing the software development right. That is quality assurance plan. Whereas testing is done after the software is completed. to make sure the software that you're receiving meets the standard, or is it fit for use. So two different things. Okay. So 3 and 4 are required activities for a certain project. So we need to figure out what kind of projects is required or available, and then we develop in the beginning the QA plan, and at the end the testing. Of course, the testing plan is also developed in the beginning, but the testing happens once the software is developed. So these are the 4 learning outcomes of this unit. There is also a basic outline of the syllabus. Okay, so what are we going to do and how are we going to do? So there are few pointers here. So we are looking at software quality. How do you classify errors? And then we're also looking at quality assurance objectives. Why are we doing this? And we're also looking at software engineering and quality assurance as processes. Okay. And then see, it goes hand in hand with software engineering. So this is why it's a part of software engineering, right? It's not a different or a separate thing. And then number 2, we look at the available systems when it comes to software quality assurance. So SQA, or software quality assurance, there is some architecture that we need to look at. We also look at what are the infrastructure components. That is, when it because software engineering, as the word says, is an engineering practice, right? It's like building a bridge, building highways, building a house. So same we can say about building software. So there are certain infrastructure components that we require to build this. And when you are building a house, we bring in certain, we don't use the word quality control, but we use the word safety there, right? We need to make sure people don't die while building the house. Yeah. And also we want to make sure people don't die after they move into the house. Or we want to make sure neighbors don't die. There's something wrong in the house or something, right? Like an electrical failure or a flood or some issue. So we bring in the practice of safety practices to building the house. So we do the same thing when it comes to software building. So we bring in the safety by way of software quality assurance into building the software. So there's a lot of human factor here involved. Of course, there's a massive amount of technology factor, but then there's also human factor that we bring into the SQA. And number 3, we are looking at pre-project quality component. That is, before you even touch the computer, before you start your first line of code, there are a lot of things that you need to do. Okay, so these are called pre-project quality components. So we look at contracts with the customer. We look at the documentation, because we need to make sure your contract and timeline has enough space, so enough time for quality control work, like testing, but reviewing, also code repository management. Do we have branches? So what are you using? Are you using Git, or are you using Subversion? Are you using something else? So all those things are actually important in the beginning. You don't change your code repo system halfway. You're wasting time then, right? So in the beginning, we need to make sure you bring in all those practices into place. So that is called pre-project software quality component. Then we look at a quality plan. So we write down what is going to be in the quality plan. So what is the objective of this plan? What are the components of this plan? And then we develop that plan for a simple or a small project. Okay, that's number 4. And then number 5 is about executing the plan. So you design the plan first, and then you execute the plan with a simple project, right? So you look at the engineering methodologies. You're looking at integrating quality assurance into software engineering. And also, what is your process of defect removal, right? How do you remove defects? How do you detect removal also? Now, if you look around, most of the projects these days are web-based. Yeah. Of course, there are desktop applications, there are also mobile applications, but larger portion of the software development nowadays happen by way of web-based application. So what happens is you develop your software on your laptop or your desktop, and then you push that into something called a code repo, another server on the cloud. And from there, you push it to maybe a live server or to another one called a staging server. So what happens there? Now, what if you make a mistake and then you push it to the live server? And the entire customer base will not be able to use their system. So that is called denial of service or DOS, right? Due to some bug in software development, right? How do you stop that? You have to give access to the software developer to push code to the server, but also how do you make sure that he doesn't break the live system? So there are certain things we can do. So we look at how do you execute your plan into the live software environment. And the last one is on testing, right? So quality assurance is one. Remember, quality assurance is one thing. Software testing is another thing. So two different things altogether. So under testing strategy, we are looking at all kinds of testing. So there is black box testing, white box testing. There are also automated testing, because testing is done by a human most of the time, right? Now, how does the human do the testing? So they may be filling a form, expecting some results. So if that is the case, why can't we automate that and then multiply the number of humans easily using software? So one human and another human will be testing something, and then there's a limit as to how many things they can test, right? How many features they can test. But if you can multiply that in 1,000, maybe 10,000, maybe 1 million easily with software, that's fantastic, right? No, you're not only testing the load of the software, you're also testing different scenarios by these people. So that is called automated testing. We will also look at how that works. And also, if you look at companies like Microsoft, time to time, they release their software, they call it alpha version, right? So Microsoft Windows alpha version, or Adobe Photoshop alpha version. Now, general public cannot access that. It only comes to their partners. So if you sign up as a partner, you have access to the alpha version. But general public get access to the beta version, right? So there is alpha version, there is beta version, and then there is something called the release version. So everyone get access to the release version when it is released, but that take a long time. Okay, so companies like Microsoft, Adobe, and few other large-scale companies, they use the public, they use their customers also to test their software, right? But they don't give the pre-alpha version. So there's a lot of work going on within the organization, and then after they pass through the company's quality assurance and testing process, only they release the alpha version. Just to get more exposure from the customers to see whether the feature is right, and there are no bugs that can go into the release version. All right. So these are some of the outlines that we are looking at when it comes to our unit and the syllabus. Okay, so what is quality assurance? What is the process of quality assurance? Okay, as it says, QA processes, not one, but there are so many, that's why we call it processes, okay, play a critical role in ensuring the delivery of high quality software, regardless of the development strategy employees. Now, that's important. Regardless of the development strategy. It doesn't matter whether you are using extreme programming or agile method or waterfall method, whatever, it doesn't matter. If you have QA process in place, that process will make sure you give high quality software product. Okay, so you see, QA process is independent of the software development process. So that's a lesson, that's a point I want to have here. Okay. Now the question, why it matters? Why do we do this? Some people might think, okay, testing is wasting time. Okay. Now for those people, I've shared those videos. At least there are 5-6 cases there. So that'll, when you watch that, there's a very short videos. They're like 5 minutes, maybe less than 10 minutes each one. Please watch all of them. You will understand why software quality assurance matters. The answer is there in the videos. Okay. So if you bring it down to some bullet points, QA enhances customer satisfaction. What does that mean? When a software goes through a proper QA process, the customer gets very good software, right? High quality software, I would say, right? So ensure software meets or exceeds user expectations, leading to higher customer satisfaction and loyalty. What does that mean? Loyalty. Now imagine you go and get a piece of software and it works as it promised. But then time to time it crashes. Imagine PowerPoint software I'm using here now. It crashes midway for no reason, right? No reason. Now, will I ever use any software from Microsoft in that's the case? Well, I will think twice. Okay, maybe my experience is bad. So next time I might do something else, right? Or a mobile phone, for example. You buy a phone from a certain company and then after a while, you turn on the camera. It takes like 5 minutes to turn on the camera. Or it takes like minutes to go through photos. So it's sort of very slow. Will you buy the same brand next time? Maybe not, right? That means someone has not tested the phone on those extreme conditions. Okay, so QA is questionable there. Number two, reduce cost. What does that mean, reduce cost? Because testing is expensive, isn't it? You have to hire people, you have to get more processes. So why do you say it reduces cost? Well, look at it this way. If you don't test your software and release it, like what happened in those 5 cases, 6 cases I have in the videos, what is the cost of your organization? Now, that trading company lost $400 million in 45 minutes because they did not test the software. Imagine they hire people or they outsource software testing to someone. Will it cost $1 million? Maybe not $1 million. $100,000? Okay, maybe that's on the high side. If they spend $100,000 in their quality assurance systems, they would have saved that 400 million loss, isn't it? Compare that. $100,000 versus $400 million. It's very cheap then. That's why it says reduce costs, right? And we'll also look at a certain chart where it shows it's actually cheaper to test your software early than testing software late. It might, let's say, for example, cost you $1 to test in the earlier stage, or let's say design stage. But it will be costing $100 at release stage. And it might cost $10,000 when you give the software to the customer, because customer will never buy your software ever. And he will also make sure that other customers not buy software from you because your software is very bad. Right? So again, that comes down to your cost, isn't it? That's where we lose money. Number 3, increase efficiency. Now, what does that mean? Efficiency in the organization when it comes to building software, right? So when you have a proper software quality assurance method or a process or a team, it will actually make the life easy for the developers, because these people will tell them, okay, don't do this, do it this way, and keep your documentation here. And here's a sample how to do documentation. So the QA department is actually helping the software development department to do their job properly. In fact, to do their job efficiently. Okay. And some people hate the QA department. They think the QA department is there to find our faults. That's bad, right? That's bad management of the company. So you can't blame the developers or the QA team. So yeah, QA team is there. Part of them is to find faults, yes, but there's another big part to make sure the developers go through a certain standard way of practice, right? Now, if you take SLTC as an example, at our university, we have a QA department separately. Why do, I mean, we are not developing software, but why do we need a quality assurance department here? Now, they make sure that all our slides, for example, the slide I'm using has certain guideline given, right? Now, there is a watermark on the top right-hand corner, you can see up there, right? And there is a LMS system. And if you look at the LMS system, there is a certain block in the beginning, right? Where every unit owner need to fill that up. And then it's broken down into weeks, things like that. So So what does that mean? So let's say next semester, somebody else come and offer the same unit, right? Now, if I do my job properly with the help of the quality assurance department, the next person coming on board to deliver this unit next semester, hopefully, his or her life will be very easy because the slides are there, all according to a standard, and there are also other certain sections where I have to keep certain files. So everything is available. Unit outline, the slides, the assessment guidelines, everything. So by assuring the quality of the delivery here, the quality assurance department of our campus make sure that the life is easy for the lecturers. So we can say the same thing for software developers, right? So the quality assurance department of a software development company makes sure the life is easy for the developers. Remember that. So it is not to make their life terrible. It is to make their life good by doing something called mitigating the risk. That is the last point, right? Mitigating means you are stopping before it happens, right? You stop it before it happens, which is very good, right? If you stop after happening, it might be very expensive, especially when your customer sees the bugs. When the customer finds out that you can't write good quality software, you're just losing your reputation. So that's a huge problem, right? So if you have proper software quality assurance processes, it will mitigate the risk and it will manage the project risk effectively, reducing the likelihood of project failure and budget overruns. Now, what does that mean? Budget overruns. If you don't build your software properly, you will have to rebuild. It's called rework, right? You need to rework and fix and do a lot of stuff, which will actually require more money. Yeah. So your marketing team may have estimated something in the beginning, but because of poor processes, you will need more people, more time, and more heartbreaks from your customer, which will lead into more expense. So your software building costs will be higher than your competitor. So although your price may be same, your cost is higher. That means your profit is low, isn't it? Same price, different cost. So different profits. So we can bring in some practices from the QA to make sure your profit goes up because your cost can come down. Okay, so these are the reasons why software quality assurance is important. If you look at a definition, what is software quality assurance? So it refers to the degree of which software meet specified requirement and user expectation. So it's about the percentage, for example. So there is a certain number of requirements and user expectation. So if that is, let's say, 100, quality assurance, make sure you are close to 100 or at 100. Okay. So the customer, if you ask a question, so out of, okay, the software is done, delivered to you, out of 0 to 100, where do we stand? Customer says 20%. That means customer has an expectation of 100 and we have given 20%. Okay. But if you have a proper quality assurance process, you can bring it up to 100. So the customer might say, look, I am very satisfied. I am 100% satisfied. Or customer might say, I'm about 90% satisfied. There's a 10% still something. So, but then we can always go back and see, okay, what does that 10% mean? Okay. So that's one way to look at the definition. And we can also bring in these attributes. What are these attributes? So that means various attributes are there when it comes to software quality assurance. And they collectively determine the software, overall determination of the software. So 4 points here: excellence, reliability, maintainability, and usability. Okay. So these are the collective determination. So this is the objective of software quality assurance, to give excellent, reliable, maintainable, and usable software to our customers. All right. So this is the expectation. So this is the objective of learning software quality assurance and making sure you pass that knowledge to the software development cycle. So this is also why we learn these techniques under software engineering program. Now, I have 3 excellent books when it comes to learning software quality assurance. Actually, these are not software quality assurance books, by the way, okay? These are software engineering books. And each book has an excellent chapter on software quality assurance. That's why I included these books. So the Bible from the Somerville Software Engineering, 10th edition has an excellent chapter on software quality assurance. I'm giving the edition because this is the edition I have. So if you have a different edition, no problem. I'm sure it has a section on the same thing. I'll try to share you the PDF version. Check the LMS maybe end of today. I'll see whether I can get you a PDF version of these things. So the first book is fantastic. It's the Bible when it comes to software engineering. It has a very good section on quality assurance. The next one is a concise guide. So it's a summary of lots of different things. Again, has a very good section on software quality assurance sections. So the name of the book is Concise Guide to Software Engineering from Fundamental to Application. So they spend a lot of time explaining you the fundamentals. It's a very good book. The third one is a collection of essays from lots of different people, software architecture in practice, right? So these guys have gone to different companies to study what they do and how they build software. So it's a collection of lots of learning there. And this also has a section on software quality assurance, right? So today my objective was to explain you what is software quality assurance and why this is important in software engineering. Okay, because many people think software quality assurance is about finding faults. So they misunderstand testing and quality control. So these are completely 2 different things. Quality control is one thing, software building or testing is another thing. And software building, of course, is another completely different thing. But by incorporating these skills together, our job is to make sure we make our customers delighted, right? We make our customers happy by building excellent, reliable, maintainable, and usable software. Okay. Right. That sort of ends my presentation. Any questions, anyone? I can see you have learned C as well. Is it C or C++? Well, I don't recommend C for unless you use C++ for this kind of stuff. But Java is a very mature language. Lots of tools are there. IDEs are there for generally a lot of things automatically. So I'll probably go with Java. Okay. Right. Check back the LMS for resources. I'll be updating in time to time, including video recordings, books maybe, and stuff like that. So please check on that. And if you have any questions, there is also a channel where you can have a discussion. Please post a question there if you have a question. So I'll be checking it out as well, time to time. All right.